Hello viewers, welcome to my YouTube channel Mathematics Made Easy. So in today's video, we solve this beautiful advanced integral. Alright, so if you are new to this channel, please don't forget to subscribe, like, comment, and also share. Alright guys, so let's dive in. So how do we solve this beautiful integral? This is what we are going to do first. We are going to write out the series representation of ln 1 plus x. Okay, so let me write down the series representation of ln 1 plus x. Ln 1 plus x will give us sum of n from 1 to infinity of minus 1 raised to the power of n minus 1 over n, then multiply by x raised to the power of n. All right, so that is the series representation of ln 1 plus x. So we can replace ln 1 plus x or by this series. Okay, so if we do that, we're going to have the following. So we have I is equal to integral from 0 to 1 of ln² x. So instead of you writing ln 1 plus x, we just write sum of n from 1 to infinity of minus 1 raised to the power of n minus 1 over n, then multiply by x raised to the power of n, then everything over x. Okay, now we can bring out this sum. So if we bring it out, we're gonna have the following. We're gonna have sum of n from 1 to infinity of minus 1 raised to the power of n minus 1 over n, then integral from 0 to 1 ln² x. Then if you apply the law of indices, x raised to the power of n over x, that's gonna give us x raised to the power of n minus 1, then the x. All right, so that is what we are going to have. The next thing we are going to do is to solve this integral right here. So for us to be able to solve this integral, we're going to make use of substitution. So I'm going to say let ln x be equal to minus lambda. Okay, then I'm going to say x is equal to e raised to the power of negative lambda. Then you differentiate. So we have the x is equal to negative e raised to the power of negative lambda, the lambda. So you check the limits. When x is 1, you're going to have 0. And when x is 0, you're going to have infinity. That is, if you substitute x to 0, that will be 0. That's going to give us infinity. Okay, so we are going to have a sum of n from 1 to infinity of minus 1 raised to the power of n minus 1 over n, then integral. So don't forget, I said if you substitute 0, we're going to have infinity, and if you substitute 1, we're going to have 0. Okay, then ln² x, that will be negative lambda raised to the power of 2, and x is e raised to the power of negative lambda. So we have e raised to the power of negative lambda into bracket n minus 1, and then the x is negative e raised to the power of negative lambda, the lambda. Okay, so because of this negative sign here, we can switch the limits. So we can have sum of n from 1 to infinity of minus 1 raised to the power of n minus 1 over n, then integral from 0 to infinity, then minus lambda square will give us lambda square, then e raised to the power of negative lambda into bracket n minus 1. Okay, then multiply by e raised to the power of negative lambda, the lambda. And this is going to give us, let's go to the next page. This is going to give us sum of n from 1 to infinity of minus 1 raised to the power of n minus 1 over n, then integral from 0 to 1 of e raised to the power of minus lambda n, then multiply by lambda square, the lambda. Okay, how do we get that? If you apply the law of indices right here, I'm coming. Yeah, we apply the law of indices right here. E raised to the power of negative lambda into bracket n minus 1 multiplied by e raised to the power of negative lambda. So if you split this, you're going to have e raised to the power of negative lambda multiplied by e raised to the power of negative lambda. Then, this will be negative lambda multiplied by minus 1, that will be plus. Then multiply by this e raised to the power of negative lambda. So this and this, when it's multiply each other, you have irrespective of 0, which is 1. Okay, then what is left there is irrespective of negative lambda. I think you understand how we got that now. Good. Okay, so moving on, we have to make another substitution right here. Okay, so what will the substitution making here? So we can say let's lambda n be equal to what variable should we use? Let's just use y. Okay, so if lambda n is equal to y, so that implies that lambda is equal to y over n. Okay, then we have the lambda is equal to the y over n. You check, will the limit change? Sorry, 0 to infinity. Sorry for that. That's 0 to infinity, not 0 to 1. Oh, we made a mistake there. Okay, so will the limit change? No. When you substitute infinity, you have infinity. When you substitute 0, you have 0. So what you have now is sum of n from 1 to infinity of minus 1 raised to the power of n minus 1 over n, then integral from 0 to infinity, then e raised to the power of negative y, then lambda squared, that will be y over n, then everything raised to the power of 2, the lambda, which is the y over n. Okay, so moving on, if you square this, so we're gonna have lambda, sum of n from 1 to infinity minus 1 raised to the power of n minus 1 over n. So you bring this 1 over n square and this 1 over n out, that will give us 1 over n raised to the power of 3. Then multiply by this n, that will be 1 over n raised to the power of 4. So you have integral from 0 to infinity e raised to the power of minus y, then y squared, then y. So if you solve this is gamma function, so this will now be sum of n from 1 to infinity of minus 1 raised to the power of n minus 1 over n raised to the power of 4, then that will be gamma of 3. Okay, you can check some of my videos on gamma function. Okay, so gamma of 3 will give us 3 minus 1 factorial, which is 2 factorial. 2 factorial will give us 2. So you have 2 multiplied by sum of n from 1 to infinity of minus 1 raised to the power of n minus 1 over n raised to the power of 4. Okay, so this is a form of the eta Dirichlet function. Is in this form, the eta Dirichlet function. Let me use another ink. It's in this form. If you have sum of n from 1 to infinity of minus 1 raised to the power of n minus 1 over n raised to the power of s, so this will give us eta of s. Okay, so this will be 2 multiplied by eta of 4. Okay, I recall that eta of s, so we recall that eta of s is equal to 1 minus 2 raised to the power of 1 minus s, then multiply by zeta function of s. Okay, so now we have 2 multiplied by eta of 4. So because of that formula, to know our value, 2 multiplied by eta of 4. Now using that formula to get our value, so we are going to have 2 multiplied by, so that will be 1 minus 2 raised to the power of 1 minus s multiplied by zeta of s, and then here the value of s is 4. That will be 2 into bracket 1 minus 2 raised to the power of 1 minus 4, then zeta of 4, and this will give us 2 into bracket 1 minus 2 raised to the power of minus 3, then zeta of 4. Okay, so that will be 2 into bracket 1 minus 1 over 8. 2 raised to the power of 3 will give us 8, then and zeta of 4 is pi raised to the power of 4 over 90. So this will be 2 into bracket 7 over 8 multiplied by pi raised to the power of 4 over 90, and 2 into will give us 1, 2 in 8 will give us 4. So this will give us 7 pi raised to the power of 4 over 360, because 4 multiplied by 90 will give us 360, and that will be the answer to that beautiful problem. Okay, so if you like this kind of video, please don't forget to subscribe, like, comment, and also share. Thanks for watching. See you next time.